Hi, this is Samuel Naveen, and this is my system software and comp5 simulation of deterministic finite automata. Here we have to simulate the concept of deterministic finite automata. Um, so our algorithm will be like this. So our input, our input, it will come like this: a table, DFA table, DFA transition table. Our output input string should be a b b, something like that. After that, our output should be it should accept our transition. Um, so our question is to write a program to check whether the given input string is accepted by the given DFA. Uh, right, given DFA. So going to our coding. So we started with scanner s is equal to new scanner. Our string input is temp. Um, our int our nos nops no no I j current flag. These are the int values. Our character is a temp string in string input in ch char alf is equal to char new when new char which is the character is 100. So we asking the user to enter the number of states, so that will be printed in the dot next thing. And uh, next again we're asking so again we're asking the user to enter the number of final states. Again we ask the user to enter the number of final states. So it will be stored in s dot next int nops s dot next int. Uh, again we're again asking the user to enter the number of trap states. It will be stored in knots. Again, the number of symbols in the alphabets, it will be stored in Noah. Uh, so our int state is new int nos. Final state is new int nos, and trap state is new int knots. So our int transition is int nos or Noah. It will be printed like enter the state of integers. We using for loop here for I is equal to 0, I is less than nos or I plus plus, and it will be stored in state of I. Um, Again, we are asking user to enter the final state. Enter the final state. So for final state again, for final state we are using for loop, uh, and it will be stored in the finals of I. Then we asking for enter the trap state, and it will be stored in trap. We are asking for alphabets transitions transitions. Ask after that asking for first state on input and transition to input. So it will be printed after that it will be printed the transition table you entered is it was telling the user that you entered is state by t state. Again we're using for loop there. So it will be printed as state of I. So we given here system.out.state I. For loop we using for loop. Then we're asking user to enter the string in a given alphabets. So the input it will be stored in input. J is equal to 0 for I is equal to 0. 0 I is less than into length dot length I plus plus. Temp is equal to input dot character. Then we're using for loop there. Then if temp is equal to alpha of t, j transition is j is equal to transition j of p. For loop again, we given for loop there. So if again we use for loop there, if I is equal to 0, I is less than or I plus plus. Uh, if uh, if j is equal to final, if j is finals, uh, then if j is finals, then it will be printed as a string accepted, else not accepted. So this up. So we're gonna run this program. We run this program. It will ask for enter the first, enter the number of states. I've entered three states. Enter the final state. Final state is 2. Enter the trap state. It is 3. Enter the number of symbols in the alphabet and number of symbols within 2. Enter the state integer 3, 1. Enter the final state. It is 1. Enter the trap state. The alphabets of DFS will be given here. No, sorry, alphabets of DFS. So enter the transition for the given state for state 3 on input 1. On input to state. It's not accepted. The string is not accepted. So these are some. So this is a quick lesson, and thank you. So there's a simulation of automatic finite automata to simulate the concept of automatic finite